Hi, so this video is going to be a quick refresher on unions, intersections, and complements. Right? So this symbol is the union symbol. And it can be read as or. This symbol, so simply the union symbol upside down, this is called the intersection symbol. And it can be read as and. Right? So the basic idea for union intersection of sets is the following. So the intersection of two sets are those elements that belong to both sets. Right? And the union of two sets are all the elements. So the union of two sets are all the elements from both sets. Right? So let's look at an example. So for example, let's say you're rolling a 12-sided die. So in that case, the sample space S would be equal to all the possible events, which would be we could roll a 1, a 2, a 3, a 4, etc., all the way to 12. Right? So if we let E be the event that you roll an even, this would be equal to the set of outcomes would be 2, 4, 6, 8, 10, and 12. Right? Those are all the possible ways to roll an even number. If we let F be the event where we roll a number bigger than 6, this would be equal to the set containing 7, 8, 9, 10, 11, 12. Right? So if I looked at E union F, what I'm looking for is what elements are in both E and F, right? So that would be, so you could list everything in E, and then see what's new, right? So a 7 would be new. An 8's not new, so I don't need to list that. A 9 would be new. We have a 10 already. 11 would be new from F, and then a 12 we already have written, right? So that would be the end of that, right? So in other words, these elements I'm underlining, these are in E. So I don't need to list them again because we already wrote them down. So you can think of union like union is often used for the term used for marriage, right? So like when you get union, you like come together, right? Or like the United States of America, right? We have a union. We came together and formed one country with all the states, right? So you're bringing everything together. Where an intersection is where you're looking at what's common, right? So E intersect F right, so E intersect F would be equal to all the elements that are common in both E and F, right? So that would be the numbers I underlined in green here, right? So an 8, 10, and 12 are what's common between events E and F. So what's often done here when we're talking about sets is you can show a picture called a Venn diagram. Right, so if I let this be my set S, and then I need to draw two circles where this is E and this is F, and then I could fill in all of the numbers that go in this Venn diagram, right? So what's in the center here, this is the overlap, right? So this would be E and F, right? So what elements would go here would be the 8, 10, and 12, right? That's the common elements. So then set E also contains a 2, a 4, and a 6, right? So that would go inside E, but not also inside F, right? And then the other numbers that are in F, but not in E, would be 7, 9, 10, 11, right? And then the numbers that are in set S that are not in E or F would go outside in this box somewhere, right? So like 1, 3, and 5, right? So now if you look here, I have all of my numbers 1 through 12 on this Venn diagram, right? So as I said before, so let me erase this. You know, if I shade in where this green is here, that is E and F, right? Where that overlap is. So then if I wanted to shade in where E union F is, the difference is that you would also include stuff that's in E but not in F, and also items that are in F but not in E. Right, so now this shading, right, so shading in both circles, this shading, all of these parts would represent E union F. Right? All right, so now let's introduce another event, G. So I'm going to keep E to be it was rolling an even, right? So 2, 4, 6, 8, 10, and 12. I'm going to introduce a new event, G. Let's let that be the event that you roll an odd, right? So that would be 1, 3, 5, 7, 9, and 11. So if I look at E union G, right, that would be equal to everything. So combining E and G, right? So in other words, notice that E's all my evens and G's all my odds, right? All the numbers are even or odd. So what we end up with are just all of the numbers in the sample, right? 1 through 12. So that's just equal to S, right? So if we didn't want to write it this way in this order, right, we could also have written, just writing E down, so 2, 4, 6, 8, 10, 12, right, is another way to think of it. And then we're going to add in G behind, so everything that's in G that's not in E, which is just everything in G, right, because there's going to be nothing in common, right? So when you write a set, the order of the elements in the set don't matter, right? So these two sets are the same. They're both equal to S, right? And then if we look at E union G, like I said, there's nothing in common, right? So how we show that? So this would be a set with nothing in it, right? Because there's nothing common between the set of even rules and the set of odd rules. There's not a common number, right? Nothing in common. So this is referred to as the empty set. So we can write it in this way with a set notation, right, with nothing inside. Or you can show it as like a 0 with a slash through it. That's called the null value, right? So these two symbols are different ways to represent the empty set. So if this is the case, if E and G is equal to the empty set, we say in probability that events E and G are mutually exclusive, right? Meaning that there's nothing in common. So when you look, if we were to look at a Venn diagram between the sets E and G, and so here we would have 1, 3, 5, 7, 9, 11, and then over here we would have 2, 4, 6, 8, 10, 12, and that's all the numbers, right? So I'm not going to have anything on the outside of the circles, and notice there's nothing in between, right? Because there's nothing in common, nothing in the middle. So in other words, I could redraw this Venn diagram where the circles have no overlap. Right, and that would be perfectly fine too, right? So this is just showing what those two would look like and emphasizing that E and G is the empty set, right? There's no common elements. Okay. So then the last thing that we want to talk about is a complement of a set. So a complement of a set are the elements well here. So a complement of a set, how about this? Is the set of all elements that are not in that set. Right? So in other words, if you remember, S is the set of rolling a 12-sided die, right? So it's the numbers 1 through 12. F was equal to rolling a number bigger than 6, right? So that was 7, 8, 9, 10, 11, 12, right? So then if I wanted to find the complement of F, so the complement of F, which we denote as F with a like a C power, if you will, right? It's a superscript C, right? It's not an exponent, but like in that spot. That's how we denote F complement. So that would just be the set of everything that's not an F, right? So like, in other words, if I look at the sample space and I cross out everything that's an F, then what's left is what F complement would be, right? So this would be equal to 1, 2, 3, 4, 5, 6. Right, so if I wanted to draw a picture of this, right, where here is the set F. So we have 7, 8, 9, 10, 11, 12. Here's set S. Then what's not an F, would be outside, which would be 1, 2, 3, 4, 5, and 6. Right, so all of this shading, so outside the circle, that represents F complement. Right, the complement of F. Now I could have seen a picture that we had up here. Right, if we drew a picture like this again, you could still find F complement. Right, so if here's S, and then I have the sets E and F drawn together. So here would be 2, 4, 6. Here's 8, 10, 12 inside here. And then we have the numbers 7, 9, 10, 11 here. Wait, not 10, right? 10 would be in the center. And then we have 1, 3, 5. Right? Let me see if I might have made that error up here too. I did. So fix that in your notes, right? I shouldn't have wrote 10 here as well. Right? So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, I have all the numbers. I just accidentally wrote the number 10 twice, right? So, excuse me. Right, so we have that shown. So then F complement, right, if I wanted to shade that, that would be anything outside of this F circle, right, including this part here, which is the part that E covers but doesn't overlap with F. Right, so all of that is F complement. Right, so F complement is still the set of 1, 2, 3, 4, 5, and 6. All right, so that's all I have for reviewing set notation.